Hello, we are from Group 1, Section 04P for subject BMM 2521, Engineering Mechanic Lab 2, and we will present the experiment rolling disc on the inclined plane.
My name is Wan Muhammad Razi Marushdam bin Muhammad Rashid. Today I will present the introduction. Galileo also saw this phenomenon and understood that it contradicts Aristotle's assumption that heavier objects fall faster. Galileo then proposed that in addition to gravity in downward force, there is an upward force exerted by air. If air resistance and friction are negligible, all objects fall toward the center of Earth with the same constant acceleration regardless of mass in a given place. Since gravity changes with a location, this constant acceleration is gravity. The amount of acceleration of free fall is g equal to 9.81 meter per second square. The final speed of a free falling body depends on the head which it has fallen. V equals to plus 2gh. The moment of inertia, when a disk is allowed to roll down an inclined plane, it accelerates in a consistent manner. The amount of acceleration is determined by the angle of inclination and the moment of inertia, which serve as a brake depending on the mass distance from rotating axis. A body can have varying moment of inertia. The mass moment of inertia for a variety of bodies are detailed in the literature. The moment of inertia is defined as J equals to half m r squared. The acceleration is calculated as follows: as acceleration equals to mg sine acceleration r squared over j.
Hello, my name is Josh Gibson. Today I will present about procedure. This is our material that we use: vernier calipers, meter stick, ruler, marble, ping pong ball, clay, and protector. First at all, use the vernier calipers to measure the diameter of ping pong ball. After that, use the same vernier calipers to measure the diameter of marble and then put the value of diameter into the data. Step 3 is set the inclination of the inclined plane. Use the ruler and protector to measure the degree and height of meter stick. Step 4 is put the ping pong ball at the end of the meter stick and then let the ping pong ball go and start the stopwatch. Stop the watch after the mid of point has reached measurement mark. Next, use the marble and repeat the step 4. Lastly, repeat step 4 by increasing the angle of inclination from 1 degree to 7 degree with increment of 1 degree. That's all from me. Thank you.
Hello, my name is Stephen Wong Tek Ching, and I will present the result that we obtained from this experiment. This is the properties of the ball that we use in this experiment. The first is a ping pong balls with diameter 39.8 millimeter and the mass is 2.3 gram, and the marble with diameter 16.1 mm and the mass of the marble 5.1 gram. This is the result that we obtained for the both ball, ping pong balls and marble travel in rolling in a distance 450 millimeter. The angle that we use in this experiment is 1 degree, 2 degree, 3 degree, 5 degree, 6 degree, and 7 degree. And we calculate the when we recorded the 3 times of the time taken and to calculate the average of the ping pong balls and marbles travel in this distance. And as we can see from the table, as the angle of inclination increase, the average of time taken for the ping pong balls and marbles will be decreased when it rolling in the distance of 450 millimeter. This is the result for the ping pong balls roll in the distance of 450 millimeter. And as we can see from the table, as the angle of inclination increase, the acceleration also will increase. However, the calculated time will be decreased. And we can calculate the deviation of the ping pong balls by using the formula that measure time that we obtain from the experiment minus with the calculated time and divided by the calculated time 100%, and this is the result for the deviation of the ping pong balls for this experiment. Next is the result for the marbles roll in the distance of 450 millimeter. And as we can see from the table, as the angle of inclination increase, the acceleration also will increase, but the calculated time will be decreased. And we can calculate the deviation for the marbles, same with the formula that I mentioned before. And this is the result for the marbles roll for the distance of 450 millimeter. And that's all from me. Thank you.
My name is Muhammad Ali Haikal bin Abdul Manaf. So I will present my part, which is discussion for question number 1 till number 7. So first question is how to adjust the angle of inclination. From our experiment, to adjust the angle of inclination, we rotate the height adjuster until an angulometer shows the desired angle. The second question, what is the purpose of angulometer? The purpose of angulometer is to measure the angle of inclination. From our experiments, we need to ensure that angle of inclination is precise, which we want to avoid any errors that happen. The third question is, can you give an alternative method to measure the angle of inclination? In my opinion, the alternative method that I can measure the angle of inclination in this experiment is by an inclinometer and also by using trigonometry method. Then the fourth question is how to make a precise alignment for this experiment. For our experiment, to make a precise alignment, we make sure the 3 bubbles is in the middle by turning the height adjuster spindle before we carry out our experiment. The fifth question is why the angle higher than 7 degrees cannot be used for this experiment. From what we have obtained a result, the angle higher than 7 degrees cannot be used for for the experiment because the time taken for roll and the distance travel will be slow. Next is the question number 6. Give the definition of free fall theory which discovered by Galileo. The definition of free fall theory which discovered by Galileo is the object fall with the same acceleration. So it requires an equal time taken to fall and also distance traveled by falling body from rest to the end. And also the last question, give the factors that cause free falling body. The factors that cause free fall body, the first is the absence of air resistance, and the second answer, shape and size of the object, also the factors that cause a free falling body. I think that's all from me for my part. Thank you.
Okay, Assalamualaikum and very good day. Okay, my name is Muhammad Mustafa. So I'll be presenting the rest of the discussion and the conclusion. So the eighth question is, what is the relation between angle of inclination and the rolling disc? Based on the experiment that has been done, the larger the angle of inclination, the faster speed of rolling disc rolling down the inclined plane. The next question is, explain the term of inertia. All right, Newton's first law of motion or law of inertia states that if a body is at rest or it is moving at a constant speed in a straight line, it will remain at rest or it will keep on moving in a straight line unless there is an external force acting upon it. Okay, the next question is why repeatability of the measurement is important. This is because we human has our own judgment error in terms of misclick of the stopwatch, or we misjudge the position of the rolling disc and so on. By repeating the measurement, we can reduce the error by some margins, and thus making it more accurate. Okay, the next part is the free body diagram of the disc roll on an inclined plane. Next question is why deviation occurs between calculated and measured value. All right, because there will be human error occurs when taking the measurement and while doing the experiment. Okay, so for example, there will be meniscus error when we taking the measurement by using a ruler and we take the measurement directly from reading it with our eye. So that is the reason why the deviation occurs. And in addition to that, there will also be an error when we're taking the time taken for the rolling disc to reach the end of the plane. Last question in the discussion part is any suggestion to improve the experiment. All right, so from our point of view, a longer plane can be used so that the time taken for the rolling disc, ball or marble to reach the end of the plane is not so fast, so that the timekeeper can be more prepared. Lastly, the conclusion. We can conclude that with an angle of inclination of 1 degree to 7 degree, the smaller size but larger mass marble took longer time compared to the larger size but smaller mass ping pong ball to reach the end of the plane. In angle of inclination of 2 degree, the T mean for marble is lesser than ping pong ball. It's because there is an error while taking the measurement of ping pong ball. These deviations shows that more improvement should be made to the experiment in the future so that the deviation would not be too high, so that it would not have any large deviation between calculated and measured time taken for the ping pong ball and marble to reach the end of the plane. With that, I thank you.